In the previous video we have seen how to solve using tangent substitution. In this, let's see how to solve using secant substitution. So if you have an expression of the form u square minus a square, then you can substitute u is equals to a secant theta. Here we have x square minus 1, so I can write this as x square minus 1. From this x is equals to u, so I can write this as x is equals to secant theta. Since a is 1, we can write x is equals to secant theta directly, and differentiating on both sides with respect to theta, we get dx is equals to secant theta tan theta d theta. And now we'll not forget to draw the reference triangle. So let's draw the reference triangle, and let's take this as theta, and we know x is equals to secant theta, so the hypotenuse will be x and the adjacent side will be 1, and the opposite side will be x square minus 1 using Pythagoras theorem. So let's start solving this integral of x minus 1 by root of x square minus 1 dx. So we know x is equals to secant theta, so you can write it as secant theta minus 1 by root over secant square theta minus 1, and in place of dx you can substitute secant theta tan theta d theta. So I write this as into secant theta tan theta d theta. So this will be equal to secant theta minus 1 by tan theta into secant theta tan theta. Don't forget d theta here. This tan theta and this tan theta cancels out, and you're left with integral of secant square theta minus secant theta d theta. And we all know the integral of secant theta is tan theta, and integral of secant theta is log mod. This is integral of secant square theta, and integral of secant theta will be equal to log mod sec theta plus tan theta plus c. And from the reference triangle you can find the values of tan theta, secant theta. So from the reference triangle you have tan theta, which is opposite by adjacent. You get tan theta is equal to root of x square minus 1 minus log mod secant theta, which is hypotenuse by adjacent, which will be equal to x, plus we already found what is tan theta, so you can directly write it here. This will be equal to x square minus 1 plus c. This is the final expression of integral of x square minus 1 by integral of x minus 1 by root over x square minus 1 dx. In the next video I'll show you how to solve an integral containing an expression a square minus x square, where you substitute x is equals to a sin theta.